Hello everyone. We are going to discuss Class 8 Science NCERT Chapter 4 Materials, Metals and the Non-Metals. So first of all we will see what are metals and the non-metals. The metals are the solid materials which conduct heat, electricities. They are hard, shiny, malleables, fusibles and the ductiles. While the non-metals are the substance which do not exhibit the metallic properties. The examples of the metals are iron, aluminium, copper, while the examples of the nonmetals are oxygen, sulfur, and etc. So the metals and the nonmetals are distinguishable by by their physicals and the chemicals properties, just like the physical properties, just like the color, the luster, the sounds, its malleability property, the ductility properties, and the chemical properties of the chemical reactions. So the appearance and the hardness of the materials, the material is like iron, it is reddish brown color and the hardness is very hard. The coal, it is black colors. The sulfur, it is yellowish powder. The aluminium, this is shiny, and the copper, this is also so shiny and very hard. The physical properties of the metals and the non-metals, as we see the blacksmith beating a iron piece or an article made of the iron like a spade, and we hear the sound of the ton when he beats the materials. So there is an activity in which we have taken the four materials: a small iron nail, a coal piece, a piece of the thick aluminium wire, and then the pencil lead to illustrate the mechanisms of the malleability of the materials. So see this video for this activity.
Metals are malleable. In this module, you will learn that metals are malleable. For this activity, we need a small iron nail, a piece of coal, a pencil lead, a piece of thick aluminium wire, and a hammer. To start with, beat the iron nail with a hammer. Hit the nail hard. You have to do it carefully. Take care so that your hands do not get hurt. Now hit the aluminium wire hard. This time also take care of your hand. What do you see? Is there any change in the shape of nail and wire? You can see that the shape of the iron nail and the aluminium wire changed on beating. When they are beaten harder, the iron nail and the aluminium wire take the shape of thin sheets or they are flattened. Now hit hard the coal piece and pencil lead with the hammer. Interestingly, you will find that coal pieces and pencil lead break into small pieces on beating. It is the property of the metals that they take the shape of a thin sheet on being hammered. This property of the metals is known as malleability. This is a characteristic property of metals. As you saw in the experiment, materials like coal and pencil lead do not show this property as they are not metals. In this module, you have learned that metals form thin sheets on hammering. The property of metals by which they can be beaten to form the flattened or thin sheets is called malleability.
So now we have seen this activity which is based on the malleability characteristic of the metals. Now the second, what is the malleability? The malleability is a phenomenon in which the metal can be beaten into the thin sheets. That means we can make the thin sheets from the metals. And then the second property is the ductility property of the metals. That means the metal can be drawn into the thin wires. That means we can make the wires from the metals, while the non-metals cannot be used for making the wires, just like the electric wire which is made from the copper and the aluminiums. Now the third property is this is of the sonorosity, that the metal have the sonorous properties. Just like when we beat the metals, they sounds a characteristic sound for each metal, as when we beat the iron and the coppers and the aluminium, all have their characteristic sounds, and we hear the different types of the sound from all these metals, while the non-metals cannot produce the sound while beaten. So the metals are hard, lustrous, sonorous, and then the good characteristic of the electricity. So these are the characteristic of a metals, while the non-metals, just like coal, sulfur, are very soft and dull in appearance. They break down into the powdery mass on tapping with the hammer, as we seen in the earlier activities. There is a general knowledge question as the metals like the sodium and the potassiums are very soft and can be cut with a knife, and while the mercury, it is only a metal which is found in the liquid state at the room temperature. So this is a general knowledge question, keep in mind this. The chemical properties of the metals and the non-metals, the reactions with the oxygens. So there is a two reactions, like the iron is reacting with oxygen and the waters, and it produces the FeO. This is a rusting mechanisms in the iron metals, as we see that there is a reddish brown rust deposit over the iron metals, while the non-metals do not react with oxygens. And then the second experiment is about the burning of the magnesium ribbon in the presence of the oxygens, as the magnesium burns in the presence of the oxygens and made the MgO. It is a basic oxide which is called the magnesium oxide, as it turns the red litmus blue. So this activity will show the burning of the magnesium ribbon. So here we see that this MgO, this is an oxide of the magnesium. It is formed and deposited in the form of the ribbon. So that's why we call this as magnesium ribbon. Now the second GK question is that when the copper vessels is exposed to the moist air for a long time, it acquires the dull green coatings. This is a dull green coatings which is deposited on the copper metal jug. This is due to the formations of this copper hydroxide and the copper carbonate. These get deposited, and this color is a grayish coating. So that's why they affect our copper metals. Now, as we observe that the magnesium oxide, it is a basic in nature, so that's why it turns the red litmus blue, while the sulfur is an acidic nature, so it turns the blue litmus red. Now coming towards the experiment, the product which is formed while reactions of the sulfur and the oxygens is the sulfur dioxide gas, and then when this sulfur dioxide gas dissolves in the water, it forms the sulfurous acid. So here this is a sulfur dioxide which is an acidic gas. It dissolves in the water, and there is a sulfurous acid is formed, and this sulfurous acid turns the blue litmus red. That means this is an acidic in nature. Now the another GK question is that the sodium metal, it is very reactive and it reacts vigorously with the oxygens and the water. So that's why we use kerosene to store it. So this experiment will give you the importance why the sodium metal is kept in the kerosene. Here we can see that when the sodium is put into the water, then it get burns and get exploded at the end. So this is a very crucial thing, that we have to store these sodiums in away from the waters in the kerosene. So the second is that the phosphorus is also a very reactive non-metal. So it catches fire if exposed to the air. To prevent the contact of the phosphorus with the air, it is preserved under the water. So first the sodium is stored in the kerosenes, and the phosphorus is stored under the water. So keep in mind these two. Now the nonmetals are generally do not react with the acid, but the metals react with the acids to produce a basic salts and then the hydrogen gas. And this hydrogen gas, when we take a candle near this hydrogen gas, this bonds with a pop sound. So this is an crucial example as the hydrogen gas bonds with a pop sound. Keep in mind this, the burning of hydrogen gas produces a pop sound. So here this table, the reactions of the metals and the non-metals with the acids. So the metal reacts with the acid to form the metallic salt, which is in basic in nature, and then the hydrogen gas which bonds with the pop sound. So when the magnesium reacted with the HCl or the H2SO4, it produces the warm water. That means they reject the energy which makes the atmosphere or the water warm. When the aluminium is reacted with the HCl and H2SO4, the same reactions takes place, the aluminum salt is formed, and then the hydrogen gas is liberated. While the iron react with HCl and H2SO4, the same experiment going to be happen. While the copper, the most important thing, the copper do not react with the HCl, so there will be no effect in the copper things. While when the copper reacts with the H2SO4, they react completely and produces the salt and makes the atmosphere warm. So while the non-metal, the charcoals and the sulfur do not react with the HCl and the acid H2SO4. Now the copper, as we see that the copper do not react with the dilute H2SO4 but react with the sulfuric acid. Now there's an 5 beakers is there. There's a crucial examples, and it's explaining the displacement reactions. So first of all, what are the displacement reactions? Displacement reactions is a such type of the chemical reactions in which the more reactive substance displaces the less reactive substance from its compound during the reactions. So the reactivity of the order of the metals are, there is a copper and the iron is more reactive than copper, and while the zinc is the most reactive than the iron and the copper. So here in the first beaker we have put it the copper sulfate is plus zinc. So when the zinc is added to the copper sulfate blue solutions, then the zinc sulfate, the salt, basic salt is formed, while the copper get deposited below the beakers and we see the red deposit in the beaker, that is of the copper. And in the second beaker we see that the copper sulfate, which is blue color, when reacted with the iron, this form the FeSO4, the iron sulfate, which is in blue green solutions we will get, this is a blue green solutions we will get, and then the copper, the red deposit of the copper in the down of the beaker. While in the beaker third, when the ZnSO4, the zinc sulfate, react with the copper, the no reactions will take place. As the zinc is more reactive than copper, so the copper cannot displace the zinc from its compound. Now the beaker D, the iron is reacted with we know that the iron is more reactive than copper. So when the copper is added to the iron sulfate, the no reactions will take place. While in the beaker 5, the zinc is more reactive than the iron. So when the iron is added to the zinc sulfate, the no reactions will take place, as the zinc will try to form the compound of its own. So the uses of the metals and the non-metals, as we use the metals and the non-metals in a various purpose, just like there's a non-essentials metals of our life, which are all the living beings inhale oxygen. So oxygen is a non-metal things. The non-metals used in the fertilizers to enhance the growth of the plants, while the non-metals used in the purple colored solutions which is applied to the wounds which acts as an antiseptic. And then the non-metal also used in the cracker. The sulfur powder is used in the crackers, while in the metals we see that the metals are the building block of any of the infrastructure of the company. We see that the metals are used for building the houses, bridges, the railroad connections, and then the much more. Now coming towards the question and answers. So first question is that which of the following can be beaten down into the thin sheets? As we see that the zinc is a metal, and this can propose a quality of the malleability. So that's why the zinc can be beaten into the thin sheets, while the phosphorus, sulfur, and oxygens are the non-metals, so they does not inhibits this characteristic of the malleability. And which of the following statement is correct? All metals are ductile. Yes. All non-metals are ductile. This is wrong. Generally metals are ductile. This is most correct, while the non-metals are ductile. This is incorrect. So the most appropriate options we will go on to take is the C options. While because of there is an exception for the mercury metals, which is a liquid at the room temperature, so it cannot be drawn into the wire. So keep in mind this is an exception metal. While the phosphorus is a very reactive non-metal, so that's why we use the water to keep it. The metals are the good conductor of electricity, while the iron is more reactive than copper, as we see in the early experiment of the 5 beakers. And then the metal react with the acid to produce hydrogen gas, which bonds with the popsa. Now the true and false is there. Generally the non-metal react with acid. This is false. The sodium is very reactive metals. Yes, it is true. So that's why we use the kerosene to keep it safe. The copper displaces zinc from the zinc sulfate solution. This is false, as we see that the zinc is more reactive than copper, so copper cannot displace zinc from its compound. The coal can be drawn into wire. This is false, as the coal is a non-metal, and the non-metal do not propose the quality of the ductility. Now some of the properties are listed in the following the table, then distinguish between the metals and the non-metals on the basis of their properties. So the appearance of the metal, there is a lustrous, and the non-metal is dull. The hardness, metal is very hard, while the non-metal are soft. And then the malleability, as the metals can be beaten into thin sheets, while the non-metal cannot be beaten into thin sheets. The ductility, the metal can be drawn into the wire, while the non-metal cannot be drawn into the wire. The heat conduction, as the metals are the good conductor of the heat, while the non-metal are the poor conductor of heat. And then the electricity, as the good metals are good conductor of electricity, while the non-metals are the poor conductor of electricity. Now question number 6, the give reasons of the following. Aluminium foils are used to wrap the food item, as the aluminium foils are used to wrap the food item because the aluminium metal is malleable, so therefore it can be beaten down into the thin foils which cover the food. And then the B part, the immersion rod are for heating the liquid, are made up from the metallic substances. The metals are the good conductor of electricity, so therefore the immersion rod for the heating the liquid are made from the metallic substances. And then the copper cannot displace the zinc from its solutions, as the zinc is more reactive than the copper, so that's why the copper cannot displace the zinc from its solutions. So that's why when the copper is added to the ZnSO4 solutions, the no reactions can take place. While the sodium and the potassium are stored in kerosene, as we have seen earlier that when the sodium and potassium are exposed to the air or the water, they get vigorously burnt and explode, which may harm us. So that's why they are stored in under the kerosene. And then the question number 7 is there. Can you store lemon pickle in an aluminum utensils? Explain. The lemon pickle cannot be stored under the aluminum utensils because the lemon pickle, this is an acid which react with the aluminum. This is a metal and liberate the hydrogen gas. So that's why they forms the acid based reactions can take place, and we will see that the hydrogen gas is liberated and it can spoil our whole pickle. So that's why the lemon pickle cannot be stored in the aluminum utensils, so we store it in the plastic jar. Now the match the column is there. The gold is used for jewelry, the iron is used for machinery, the aluminium is for wrapping food, the aluminium foil, the carbon is used for the fuel, the coal, and then the copper is used for making the electric wire, as because of the ductility properties. The mercury is used in the thermometer, as the mercury is liquid at the room temperature. Now what happens when the dilute sulfuric acid is poured on a copper plate? So when the dilute sulfuric acid is poured on the copper plate, the copper metals react with the sulfuric acid and liberate the hydrogen gas. As the copper is a metal, and the metal react with the acid to form the metallic salt, and liberate the hydrogen gas. So this reaction is taking place. while the iron nails are placed in the copper sulfate solutions, as the iron being more reactive than the copper. So the copper cannot displace iron from its solutions, so the blue color of the copper sulfate fades away and there is a deposited of the copper on the iron nail. So the iron react with the copper sulfate, and then we get the iron sulfate as a product, and then the copper get deposited on the in the iron nails, or even we see on the floor of the beaker. Now the question number 10, the Saloni took a piece of the burning charcoal and collected the gas evolved in the test tube. How will she find the nature of the gas? So the process is that add a few drops of the water in the test tube containing the gas. Now cover the test tube and shake it well. After shaking the test, the solutions with the blue litmus and the red litmus, it will turns the blue litmus red. So that's why we see that when the blue litmus get turns into the red, it gets say that this is an acidic nature, while the red litmus remains red. So that's why we see that this is in acidic in nature. So write down the word equations if of all the reactions taking place in this process. So there's a charcoal, when reacted with oxygen they form the carbon dioxide, and with this the carbon dioxide, when we add water, they form the carbonic acid. As this carbonic acid is a weak acid, so that's why the acid turns the blue litmus red. Now the question number 11, the one day the Rita went to the jewelry shop with her mother. Her mother gave an old gold jewelry to the goldsmith to polish. Next day, when they bought the jewelry back, they found that there was a slight loss in the weights. Can you suggest a reason due to this loss? As we see that the goldsmith polished our gold ornament. That means the goldsmith dipped this ornament into the liquid called the aqua regia, which is a mixture of the hydrochloric acid and the nitric acid, as in the ratio of the 1:3, means one part of the nitric acid and then the 3 part of the HCl. So on getting the environment of the aqua regia, the outer layer of the gold dissolves and the inner shining layer appears. So that means some of the gold get dissolved in these solutions, and so that's why some of the gold get dissolved in these solutions and there is a weight loss in our ornaments. So this is the reasons of the weight loss. So this is all about the chapters. Please do share and subscribe this channel for more video lectures